All right, hello chemistry students, Mr. Diego here with another short video. The last video that I went over talked about empirical formulas and molecular formulas, and we did the calculations for empirical formulas. For this video, what you're going to need is a periodic table and a calculator. This video should be a little bit shorter than the last one. So empirical formulas, simplest whole number ratio, molecular formulas are actual ratios. We looked at some examples and we talked about calculation steps. So to calculate the empirical formula, you have 3 steps. You need to convert to moles, divide by the smallest number of moles, and then construct the simplest whole number ratio, which is the definition of a. In this video, we're going to talk about the steps for calculating a molecular formula. So in calculating a molecular formula, what you need to do, there's also 3 steps. So step number 1, you are going to calculate the molecular mass of the empirical formula. Number 2, you're going to divide the molecular mass of the molecular formula by the molecular mass of the empirical formula. Spell it. And in step number 3, we're going to multiply empirical formula by result of step 2. Okay, so lots of words. Let's get into some practice problems. Okay, so in our last video, we calculated the empirical formula for question number 1. So now we're going to calculate the molecular formulas. So the empirical formula is C2H3O4. So for step number 1, what I need to do is I need to calculate the molecular mass of C2H3O4. Okay, so I have carbon. Looking at my periodic table, carbon has 12.01 grams. And in this formula, I have 2 of them. For hydrogen, it has a molecular mass of 1.01 grams, and I have 3 of them. And for oxygen, I have 16.00 grams, and I have 4 of them. So when I do that, 12.02, 12.01 times 2 is going to give me 24.02 grams. 3 times 1.01. 1.01 gives me 3.03 grams. And 16 times 4 gives me 64.00 grams. When I add these up, 64 plus 3.03 plus 24.02, I get 91.05 grams. Okay, so that's my molar mass for my molecular formula. Okay, so step number 2, I'm going to divide the molar mass of my molecular formula. In this case, that's the value that's given right here. It will be given to you in the problem by the molar mass of my empirical formula. So step number 2, I'm going to divide 91.0 by 91.05, and I get 1. Okay, in step number 3, I'm going to multiply this number, the 1, by my molecular or my empirical formula, so C2H3O4. I'm going to multiply it by 1. And that will give me my molecular formula. So in this case, my molecular formula is going to be the same as my empirical formula, and that happens from time to time. Okay, so let's look at question number 2. Question number 2, step number 1, I want to find the molecular formula. Step number 1, I'm going to find the molar mass of my empirical formula. So molar mass of C3H8. So carbon, I have 12.01 grams times 3. And for hydrogen, I have 1.01 grams times 8. So when I calculate this, 3 times 12.01 gives me 36.03 grams. And 8 times 1.01 gives me 8.08 grams. And when I add these together, I get a molar mass of 44.11 grams. And so that's step number 1. In step number 2, I'm going to take the molar mass of my molecular formula, which is 132.0. And I'm going to divide it by the molar mass of my empirical formula, which is 44.1. And when I do that, 132 divided by 4.11, I'm going to get 2.992. So we're going to call that 3. Okay, and then the last step, what I'm going to do is I'm going to take my empirical formula, which is C3H8, and I'm going to multiply it by the value that I got in step number 2. So I'm going to multiply everything by 3. So now my value becomes C9H24. So that would be my molecular formula. Okay, hope that was helpful. If you have any questions, please send me an email. Thank you.